In this video, we will learn how to find minimum or maximum points from a real-life situation or an application question using differentiation. Hello everyone and welcome to Mathematics, where this channel is able to help you to build up your habit incorporating a question a day in mathematics. So for today's video, we will look at a question from Book 5 Chapter 2, Differentiation. So before we begin, y'all can take a look and try it by yourself first. Here, Amrin has a piece of wire and wants to make a cuboid shaped box frame, which is displayed on the right side. So now they're given us two important information, which is the volume of the box is 375 cm cubed and the base length is twice of the base width. And by looking at part B1, you can see that it tells us to find the value of P, which is the shortest. So here it is actually an optimization problem, whereby giving a problem, find the minimum value or the maximum value. So this involves an application in differentiation, which is to find turning points or to find the minimum or maximum point. So here I will introduce a 4-step method from an optimization problem to find the minimum value. But for the steps, I will split it into two questions to explain. For step 1, I will explain in part A. For step 2 to 4 will be in part B1. By looking into part A, our base width is x, and we need to show that the length of wire used is this equation. Now let us just find the length of wire first. Since the width is x and the base length is twice the width, so the length will be 2x, and for the height it didn't give us anything, so we just put a y first. And since cuboid has 4 lengths, 4 widths and 4 heights, so we can just multiply 4 for each of the sides and add it up together. Now what you can see here is by comparing our equation with the question's equation, you can see that this one is the same, but this is different. Ours is y, theirs is x. So this involves the first step. Express equations using one unknown only. So here we have x and y. We need to change this y to x. One of the ways to transform y is to use the information in the question, which is the volume of the box. So we can use this information to form an equation and substitute x into this y. So our volume of the box would be length times the width times the height. So since we are substituting x into this y, so we need to form an equation that y is on the left. And we sub this equation to y. And you can see that the question that we have is same as the question. For part B1, we are trying to find the value of x, and we need to make sure the value of P is the shortest. So here meaning we need to find the minimum point. So to find the minimum point, we need to use the equation that we have differentiated equals to 0. This is because it helps us to find the turning points. So turning points can be two. One is the minimum and one is the maximum. So in another video, I explained this in quite detail, so I'll put the link in this video. So now let's differentiate our equation first. Using plus as a separator, differentiate part by part. So here remove the x, here we will multiply the power and the number. And change dp, dx to 0. So step 3 is quite straightforward. We just need to simplify our equation to find x. And our x is 5 cm. So there's another step where students will forget, which is to prove that this x equals to 5 will cause P to be the shortest. So this involves step number 4. to prove it is minimum or maximum value. So one of the ways to differentiate minimum and maximum is we can calculate the second order differentiation value. So if it's more than 0, it will be minimum, less than 0 will be maximum. So here, let's differentiate this equation one more time. 12, if I differentiate, it will become 0. Here, number multiply the power. And without substituting the x into 5, we can already see that this is positive because our x is positive and 4500 is also positive. So since this is positive, the conclusion would be this is a minimum value. And for part 2, we need to use the x that we found here to find our value of p. So it's quite straightforward. By substituting x into 5, you will get 90 cm. And for the last question, it tells us that for a wire's price for a meter, it will be 1 ringgit and 80 cents, and there are 30 participants. So what is the price that the organizer have to spend? We convert this into meter first, and since for each meter is 1.8, we just multiply, and since there are 30 participants, we multiply another 30 to get in total RM 48.60. And we have completed this question. So the take-home point for this video is, when it comes to optimization problems, we need to use the 4-step method to help us find the minimum or maximum value. So the first step would be making sure our equation has only one unknown. So we need to transform, let's say, the y into x. So one of the ways to help us convert is to use the information in the question. So for example, we use the volume of the box, form an equation, and use that equation, sub it into here to make sure our equation has only one unknown. And the second step would be differentiating our equation and equal it into 0 to find our turning point, which is either minimum or maximum value. And step 3 is to find our x. Step 4 is to differentiate our equation again to see it is a minimum or a maximum. So minimum will be more than 0, maximum will be less than 0. So if you are interested in this question's answer scheme, you can click the link in the video description. And if you feel this video is beneficial to you, please give a like, subscribe, and share it to your friends and classmates. And if you have any questions, feel free to comment below. So I'll see you all very soon in the next video. Thank you.